Okay, good morning, ladies and gentlemen. Okay, guys, my name is Mok. Just call me Mok. So my contact information is there. I'll be taking you guys for this week, and you probably won't see very much of me after today. You see a bit of me. I'll do some lab briefs down the road. But feel free to make an appointment with me to see more of me if you want. Okay. I'm very easily contactable via Telegram. Some people mind, but I don't mind. You can even message me at night. It doesn't really matter. Okay? Because if I don't reply, that means I'm sleeping. Just don't call me after midnight. Very dangerous. My wife picked up the phone and then he's a girl who's jialat. Or worse still, if it's a guy, even more jialat. So message me, okay? You can message me anytime, Telegram, WhatsApp, to make an appointment, or if you have any questions about programming, your lab tests, your project. So my area of coverage for this course will be all the programming related stuff. Try not to ask me about counting and all the other areas. That one you go back to Hardy, okay? Okay, this is a slide from last week. So Hardy was saying that this is not really a programming course, but you need to articulate your algorithms. That means you need to implement your algorithms in the form of a Python program for your project, which means anyway you have to learn programming. So for those who already know programming, it's a revision. For those who have never done programming, don't worry, this course is not meant to disadvantage you. So we are taking great pains to ensure that students who have never ever done programming are not disadvantaged. Okay? Later I'll talk about the supporting mechanisms we have. And in fact, you can actually, as a bonus, you learn extra stuff. Programming is like coding, the very hot thing which everyone wants to learn. Even the business students want to learn, to get a bit of taste of nowadays. So you also have a lab test, which is worth 10%. Individual programming tests, we'll prepare you for this, don't worry. Okay? You're allowed to give your solutions as pseudocode. Now, for the written part for this course, quizzes and exams, as long as you use a pen to write, you do not have to write your answer in the form of a Python code. Alright? In other words, if the question is come up with an algorithm or design an algorithm to do something, you can write your answer in the form of pseudocode. That means something like English. We won't punish you if you actually don't write Python code. Alright? So now your two questions will be, have you set up Python correctly, and have you set up Python labs correctly? So we'll be making use of these two today, quite soon. So if you have not installed Python, please do it now. Probably take about 2 minutes. Okay, it doesn't matter whether you're using a Mac or Windows. Now, this thing idle, IDLE, is installed by default with any Python installation. So in other words, if you have installed Python, you already have idle installed. So what does idle stand for? It stands for Integrated Development Environment, which is just a tool. If I purposely put an L here to differentiate these two from other IDEs. IDE stands for Integrated Development Environment. So how do you actually start idle? So for the Windows people, just start and type IDLE. Okay, you should be able to see idle there. Okay, just hit enter and it starts. Okay. Now for the Mac people, so this is how idle looks like. It's a command shell. Alright, you see this bigger sign. This is the Python prompt. Alright, in other words, it's waiting for you to enter a command. The cursor is blinking there. It's waiting for you to enter a command. And of course, you can see the Python version and stuff like that. Now for the Mac people, I believe it should be under Applications, Python 3.7, and then you can find idle shortcut there, or the application there. Alright, so we'll be using idle for today's demonstration, for today's exercise. Now, besides Python, I need you guys to set up Python labs. Alright, in idle, To check whether you have installed Python Labs successfully, you can type this from pythonlabs.tools import start. Now, Python Labs, capital P, capital L, tools, capital T. The from is small f. You realize that Python is case sensitive. In other words, a small f is different from a big F. So be aware of the capitalization. Alright? So if you type this and you hit enter, and there is no error message, it's good news. That means Python Labs has been properly installed and you're ready to go. On the other hand, if you get an error message saying module not found error, alright? By the way, if you ever see an error message, please study the error message. Don't so many weird text and ignore it, and then you'll be clueless. Error message gives you an idea of how to solve the problem. So it says module not found. No module name, Python Labs.tools. Now Python Labs is what we call a module. It's not found. So two possible reasons: either you have not installed it correctly, or there's a typo mistake. Maybe you say Python Lab instead of Python Labs. So look at the name and retype it. So you need Python Labs installed for not so bad, second half of the session. So what is a module? Since we are talking about Python Labs, a module is basically a bunch of code written by someone. So in this case, Python Labs was written by the author of the JSC textbook, written by JSC himself, and he wrote it and he uploaded it for anyone to actually download and use. So it's a bunch of code, and you need his code, you need his functions for certain exercises later. So for this course, demonstrations and examples will be shown using either, but if you don't like either, which is a built-in and very basic tool, you may choose to use any other code editor. I mean, I don't really care why, because for your lab test, for your project, you'll be submitting the outcome, the code. Okay, how you create a code, you can use Notepad, you can use Sublime Text, you can use either, I don't care. I don't see anyway. Alright, so you can use any other tool. If you are a fan of Microsoft, you can use Visual Studio Code. Getting very, very popular nowadays. The textbook mentioned this tool called IDP, and now it's called Paizo. I haven't really tried this, but you can get it if you want to. So things like Visual Studio Code, you have to go and search for and install some Python plugin, so you can actually run Python code within Visual Studio Code. You don't need to run Visual Studio Code and then run either, and then it's so troublesome. Okay? So you have to, if you want to download one of these tools, go and find out how to actually run Python from within that tool itself. Okay, another thing is, for this course, we're using Python 3 point something. Okay, something can be 6, can be 7, can be 5, not really important. Not Python 2 point something. So if you have an older version of Python, no, please upgrade to 3 point something. Latest is 3.7. Alright, why? Because there are some differences between 2.x and 3.x. And your code for your lab test and your project will be submitted to the server for automatic marking. And the Python on the server is 3.x, which means that if you use 2.x, if it runs happily on your laptop, it may not run happily on my server. And that matters more than it runs happily on your laptop, because that's the marker. Alright, so use 3.x. So the reference text, okay, today's session will be very, very, very closely aligned with chapters 2 and chapter 3 of this JSC textbook. Alright, I mean, I find the exercises there quite good, so I mean, might as well make use of it. And the second thing is because there might be some students who might join us later. Drop ends next Monday, 10 a.m., right? Okay, so for those who join later, maybe a couple of people, they may still follow the course by reading the 2 chapters. Now, this textbook, I find this textbook very easy to read and understand. So Hadi may not refer to this textbook down the road, but there are actually chapters in the textbook which correspond to his lessons, except for next week's lesson, which is complexity. That's the only thing missing. Okay, besides complexity, he will talk about traveling salesman. You will find a chapter in textbook on traveling salesman, etc. So it's still quite easy to read, bedtime story, like that kind of thing. So the author has kindly put up a PDF version. I suspect that this PDF version is the pre-production version because there are some 12 typos there, but anyway, you can get the pre-production version here, the PDF file, right? Or you can get from library. I think there's some copies from library, or you can buy it if you want to. Right. Now, by the end of the first half of this session, you should have written a simple Python program. So I was saying this just now. Now, programming language for this course is Python 3.x, and this is the first time we're using Python for this course. In the last five years, we have been using Ruby. Ruby is another language which is very, very similar to Python. Okay, so this is the first time we are converting from Ruby to Python, and so there may be some kinks and down the road and stuff like that. Okay. So Python is very commonly used in the industry. Okay. In fact, I was reading some literature and I realized that a lot of the North American universities, Python has overtaken other languages like Java as the first language chosen to be taught in for com science people. Alright. So another reason why we chose Python is because a lot of libraries have been written, a lot of modules have been written for analytics, for anything out there. So it's useful to learn Python, I must say. So 3 things required only. Okay, the Python you have installed, Python Labs written by the author of JSC, and any code editor, or if you want, can use either which is already packaged with Python. It's a simple language, yes, very much simpler than Java. Okay, those who have learned Java or maybe even C or C++ will find this a very, very nice, very easy to learn from. By the way, if you're already an expert in Python, you don't have to really follow this lesson. What I'll suggest you is that instead of watching YouTube or playing games, right, you may want to do the Code Academy, Code Academy, whatever. Codemy thing, which your TA, you send them email the link, right? So I think at the end of week 5, your TA is the owner for this Code Academy thing. He's going to check if you have achieved a certain batch. Alright? So you can spend your 2 hours doing the Code Academy stuff. It's going to take about 2 hours, I think, to complete that. So might as well do it here if you are already a Python expert. Alright, don't have to really follow. Alright, but if you are new to programming, please follow me. Okay, you can do the Code Academy thing later. Now, you can run Python in 2 ways. One way is the interactive way. Okay, interactive meaning you enter something, you hit enter and you see a result. You type something and hit enter, you see a result. It's interactive in nature. So you can run Python using either. It's interactive in that sense. So either is interactive, or you can actually do something like 3 plus 3, and you see the outcome which is 6. And then the prompt appears again, waiting for you to enter a new command. So you can do something like hello, good morning, kind of thing. Okay, so it reacts, it interacts in a way with you. So this is the first way to actually use Python, and for this session, we are going to use either. But there is another way to use Python, that is to run it from a terminal window. Alright, you already have the Python code in the file called whatever.py, and you run it from terminal mode. Okay, anyway, if you have time, I'll show you a quick demonstration at the end of today's session, later, second half. Okay, so idle is like calculator, it evaluates expressions. And you'll be trying these 4 arithmetic operations later, very soon. It takes 1 minute. Addition, plus, subtraction, minus, multiplication. You don't use the X, you use the star, alright? And division, you use the /. So use round brackets or parentheses if necessary, if you want to cause something to happen before something in your arithmetic operation. So let's get our hands dirty quickly. For today's session, it's going to be a lot of hands-on exercises. You do the exercise, then we do a debrief. You do an exercise and we do a debrief, so that you can see something happening. I think it's a better way to learn. So that's why I like this chapter 2 of the textbook. It's actually designed this way. So go to the textbook. Okay, it's either page 23 of textbook or page 36 of the PDF. So if you are looking at the PDF file, just on the top, just jump to page 36 and you'll see a tutorial projects there. So try tutorial 1 to 8. So if you haven't installed Python, please do it now, quickly. It will take about 2 minutes. Or if you need help, just raise your hand, we'll go over and help you. For the first half, you don't need Python Labs. For the second half, yes. So if you haven't installed Python Labs and you need some troubleshooting and stuff like that, we'll do it during the break. Okay? So let's try this now. As you do, think about what you're doing, because I think anyone can just follow instructions and do, but think about what you are doing. Alright? So let's spend about five minutes doing this, and then we will think about what we've done. We'll reflect on this. So if you need help, just shout. Okay, Wei Xiang and I will go over. So expect that. First half you go a bit slower so that you won't get lost so quickly. Now reflecting on the first 8 exercises, now the first thing you might have noticed is there seems to be some precedence rules. For example, if you do 3 plus 1 divided by 7, you realize that the answer is actually 3 plus 0 point something. And the answer is 3 point something. It's not 4 divided by 7. It's a bit different. Okay? So it seems to imply that division has a higher precedence compared to addition. In other words, 1 divided by 7 happens before 3 plus something. Okay? So if you want 3 plus 1 to happen first, you use round brackets. Bracket 3 plus 1, bracket divided by 7. To force 3 plus 1 to happen first. So I want you to quickly do a search for this this phrase, Python precedence, operator precedence table. Python 3 operator precedence table. Or table precedence. So this applies to any programming language. They will always have operators, and operators usually will have some kind of ranking. So that's anyhow. You'll be able to find the table quite easily from a lot of places. What? That's my picture. Okay. Hey, that's my picture. So easy. Alright, you should see some table like this, which shows you all the operators in that particular language. This thing on the left, these operators. And the one you have just used will be this one, plus and minus here, times and divide here. Okay, realize that times and divide is higher than plus and minus. This table is ranked. The operator at the top has a higher precedence compared to the operator below. So times and divide will happen first before plus and minus if they are on one line. Alright? Now, you realize that the bracket operator at the top, the parentheses are for grouping purposes, highest precedence. Okay? So you are not no one will expect you to memorize tables like that. I mean, if someone wants you to memorize this, that's something wrong with it. But always refer to a table if necessary. Alright? When you write your code, also try to avoid such situations. Use brackets so that it becomes unnecessary for the reader to refer to a table. Okay, so that's the first thing to do is to notice is that operators, they have ranks. And the one at the higher rank will actually happen first. So some terminologies, this plus and divide and times and minus are what we call operators. Now these numbers which work with operators are called operands. So the addition operator has got two operands, the number in front and number behind. Some operators have got one operand, only require one operand. Some operators require three operands. Okay, not very common, but yeah, there are. Alright. So other useful operators which you want to play with will be the remainder of operator, the percent sign. Okay, this is also known as the mod operator. So 10 mod 3 will give you 1. The remainder when 10 is divided by 3. What about star star? Okay, remember these two stars when you start together, if you split them, it becomes two multiplication operators. Star star means the power of operator or exponentiation operator. So 10 to the power of 3 is 1000. You can try this yourself later. Okay, some more terms. Okay, for those who have forgotten, the word integer means a whole number. Alright, like 3 and minus 1. The word float or floating point number means there's a decimal point in your number. So for example, 3.0 is a float. Even though 3.0 and 3, they seem to have the same value, but as far as Python is concerned, in fact, as far as most languages are concerned, they are different. Alright? Why are they different? This is an integer, 3 is an int, an integer, 3.0 is a float. So the types, they have different types. The value will be the same, I mean, as far as mathematics is concerned, they are same, but the types are different. So they are different because there are some implications when you manipulate them. Another thing you might have noticed is that an integer divided by non-integer in Python 3 will return a float. So 3 divided by 2 is 1.5. 3 divided by 3 is not 1, but 1.0. Okay, the outcome of division will always be a float. Now this is in Python 3. For people doing Python 2, some difference here. In Python 2, an integer divided by integer will give you an integer. Alright? So that is one major difference between Python 2 and Python 3. Now there's an operator that returns an integer only if you want to, get an integer only. You do 4 divided by /3, alright, and you get 1. Now notice that this is not a round. This is not a rounding operation. This is a truncation. Okay, you can confirm this by trying 5 divide 3. You'll get 1 instead of 2. Okay, it's a round operation, you get 2. So let's carry on T9 to T19, and then we discuss a bit more. Okay. Another 5 minutes for this. Okay, let's carry on. Let's talk about what you have just tried. Now you have seen two types of data so far. Okay, besides the integer, we have the floats, right? So integer times integer will give you an integer. But the float times an integer, this second operand, the integer will be promoted to a float, and answer will be a float. Alright, so this is the same for addition and subtraction. If one of the two operands is a float, okay, the answer is going to be a float. So we have seen a division case just now already. For division, integer divided by integer in Python 3 will give you a float. We also tried to use square root. Now this is what we call a function. Okay, very soon you'll be writing your own function. For now, someone has written the code for this function called SQRT and placed that code in a function. Now the correct term is to use a function, you say you call a function, excuse me, or you invoke that function. So when I say call or invoke a function, I mean you use it. Use it means, how to use it? Very easy, right? SQRT bracket and you pass in. In this case, the square root function requires one input. So you can pass in the input, which is 25 or 49 or whatever, in order to run that code, alright? Now T15 requires you to import SQRT before using the SQRT function. So if you do not import, what's going to happen? So I'll just quickly show you guys what's going to happen. If you do not import from the math module and you try SQRT, you'll get an error. Look at the error message. It says SQRT is not defined. You're going to see this very frequently. That means they don't know what is SQRT. This function has not been defined. Defined means not written yet. You'll probably get the same error if you just type anything. X is not defined. So what you need to do is you have to import from math. Math is the module. From math import. Can import SQRT or import star. Star means all the functions in that module. Okay, I just import this particular function SQRT and then you can use it. Alright, because SQRT function is found in the math module. Right, so just check yourself. You see, it's not defined. Either it's not imported or there's a typo. Instead of SQRT, you type SQRT or whatever. Okay. Now, what happens? By the way, if you're using idle, there's this thing called restart shell, under shell, restart shell. Once you restart the shell, you see this thing restart. Show you that yes, we restarted. You cannot use SQRT again without re-importing it. Okay, restart shell is as good as closing the whole window and restarting the program. So the SQRT is no longer. The math module is no longer imported. Everything from memory has been wiped out. Okay, so when you restart a shell, you have to re-import. When you restart a shell, later we'll talk about variables very soon. All the variables which you have been using will be all gone. Okay. Later, you will learn how to load a file from idle. Once you load a file, the shell will restart. Okay, let's move on to variables now quickly. Variables are basically temporary storage areas for a value. You can use an assignment statement to store a value into a variable. So this is the assignment operator equals. This is the assignment operator. Okay. So this is the way to assign the value to x. Or put in another way, you can say 2 is stored in x. So x is something like a box or a storage place where you can put one value inside. So x equals to 2. Now x plus 4. And hit enter, you will see 6. Why? Because they will retrieve the value stored in 2, in x, which is 2, and 2 plus 4 is 6. You can try x plus 1, you will get 3. To see the value in x, you just press hit x, type x and hit enter, and you see 2. Okay, y equals to 10. Basically, now I'm using a second variable. X and y are now what we call variables, and it's storing the value of 10. And you can do x plus y, which is 2 plus 10, and you get 12. To see the value of y, okay, you just type y and hit enter. Now look at the stuff in red on this slide. Now the circle in red stuff, this statement, and this statement, these two statements circle in red are what we call assignment statements. There is an assignment operator there, the equal sign, assignment operator. Okay, x and y are the names of the variables. Now the blue ones, these statements do not change the value of x or y. Alright, this one does not change the value of y. Okay, why? Because these are not assignment statements. These statements merely make use of the value stored in the variable. Okay, retrieve the value of x, which is 2, and add 4 to it to get the answer 6. So just be very aware of what you're doing. If there's an equal sign, you are changing the value of the variable. There's no equal sign, you are just using the value of the variable. And as the name implies, right, variable, you can vary the value of a variable. So how to change the value stored in x? Simply reassign it a new value using the assignment operator. X equals to 10. So just now it was storing 2. So 2 is crossed out. Now it stores 10. So the value has been replaced with a new value which is 10. At any one time, x can only store one value. So once you reassign a new value, the old value is gone forever. Alright, these are alarm clock. So you wake up at 9 o'clock every morning. X plus 1, you get 11 now. Okay, because now the value of x is 10. Alright? Now this is a new assignment. Now look at this second assignment. X equals to x plus 1. What does this mean? This means get the current value of x, 10. Add 1 to it, 11. So this thing on the right is actually 11. 11 is assigned to x. So the new value in x is 11 now. So learn how to read these statements. Basically, it means that whatever x was, now you change the value to the 1 plus whatever that value was. Alright? So some rules, variable names must start with a letter. You can choose any name for your variables. X and Y are not very good names because they're not very descriptive. So choose a descriptive name. If the variable is supposed to store the height of a person, maybe you want to choose the name height rather than X or I or J, So names must start with a letter, and you can use letters, digits, and underscores. No spaces, no strange punctuation marks, no dollar sign, no percent sign inside. Case is important because a small a is not the same as a capital A. Alright, for Python, and case is important. So naming conventions. Number of students is a better choice than number of students like that. This is what we call the camel notation, camel case. Okay, because it looks like the hump of the camels are all the capital O, capital S in the middle. In Python, this is preferred, although this is technically correct. So choose to use underscores to separate words to make it more readable, rather than NOOF students are one single word. Very difficult to read that word. Okay? Now let's move on to the next bunch of exercises. This bunch of exercises have got to do with finding the area of the countertop. So this is a square, let's say a square paper, and someone chopped off a triangle. So the problem here is to find the area of the remaining, I don't know what you call this shape, remaining shape here, countertop, okay, it's a counter, kitchen countertop. So how to find the area of the countertop is basically the area of the square, which is x squared, x to the power of 2, minus the area of this small triangle, which is, area of triangle is what? Half times base times height. And the base and the height are both x divided by 2, half x. Alright, so let's try this tutorial project questions T20 to T30. Okay. So let's try that quickly, 5 minutes, that shouldn't take too long. Okay, let's take a look.
Test. Okay, slightly better. Helps you to wake up a bit more.
Okay, some reflections. Now remember that assignment statements are not mathematical formulas. Okay, this is a very common misconception for people who are doing programming for the first time, because they have been doing algebra for the last 20 years. So look at T24, which you have just typed, x equals to 109, and you hit enter. And then later, at the subsequent step, you actually did this triangle equals to something, and you hit enter. And you want to see the value in triangle, it is 10395, whatever. The area of the triangle based on x equals to 109. Now, later, in step 29, you changed the value of x from 109 to 107. Now the question is, does this change the value stored in triangle? Answer is no. Okay? Now if you treat this expression, this statement, as a mathematical formula, you learn algebra, triangle is something, you may think that if x changes, the value of triangle will change correspondingly. Correct? I mean, formula ma. But this is not a mathematical formula, as in this is not a definition. At this point in time, this is when you type this statement and you hit enter, it's an assignment statement. What this means is that at the point in time, I'll retrieve the value of x, whatever is stored in x at that point in time, which is 109. I'll evaluate this expression on the right, okay, divide by 2 to the power of 2, divide by 2, stuff like that. And then that value, which is some number, I store it or assign it to triangle. After that, end of story. There's no more relationship between triangle and x. This is not a formula, not a
formula. So down the road, when I change the value in x, the value in triangle will not be affected. They are independent variables. All right? So this is a common misconception, okay, for people who are doing programming for the first time, because it looks like algebraic formula here. So this is an assignment statement. Okay. Any other insights for the past few tutorial projects you've been doing? Anything to share? Any questions which you may think are interesting? So the nice thing about this tutorial project, right, the author calls it tutorial project, is that you do a bit and then you think a bit, you do a bit, you think a bit, and you see something happening. So now you are going to learn how to write your own functions. You have used one function, which is the square root function, written by somebody, I don't know who. Okay, someone wrote it, you called it, you invoked it. Now you are going to write or define your own function for others to call. Okay, so a function is just a pre-packaged chunk of code which can be reused many times. Okay, so here you can define a function. In this case, I'm defining a function called Celsius in idle. So you can just type df, the function name, bracket. In this case, I put ff is just a variable name. And then one statement inside, return f minus 32 times 5/9. So basically, this function takes in a number. This number is the temperature in Fahrenheit. All right? And it actually converts it to the temperature in Celsius using this formula and returns it. And then you can call it or invoke it how? You call a function the same way that you call the square root function, function name, and you pass in a number. Okay, so in this case, I pass in 86. F will be 86. So the function will run. When the function, okay, this function is very short. There's only one statement inside. When it runs, it takes 86 minus 32 times 5/9. All right, results in some number, 30.0, and it returns it. So the function takes in an input. The input is f. Okay, whatever you pass over will be stored in f. It does something to f, performs some calculation in this case, and it returns the calculated value to the caller. And you see the return value printed out here in idle. So you can reuse a function. You write it once, a package of code, and you can reuse it. So second time I'm calling it, I'm passing in 100 instead. So this time I'm passing in a different input, and it comes back with a different output. All right, different input, different output. All right. So a function can be viewed as a system. Now, I'm saying that it's a bad idea to actually define functions in idle because you cannot edit the function. So down the road, when you want to change the formula, you realize there's a mistake. Instead of times 5 divided by 9, it should be times 5 divided by 8, for example. You cannot edit the code in the Celsius function. You have to rewrite the whole darn thing. So you have to rewrite that. Now, in this example, you don't feel the pain because there's only one statement in the function, but some functions can be hundreds of lines of code, very long functions. So bad idea, you do not want to actually define or write functions using idle. You want to write it and store it in a text file. So the next time you can edit the text file, save it, you can load the text file. Okay? So I'm going to show you how you can write a function in a text file and save it and load it. Okay? So very easily from idle. By the way, you should actually prepare a working folder for this course. So you may have a working folder like C/103 or C/10 and put all your code at the same place. Otherwise, everything will be very messy. Okay, under file, you can do like new file, new file, and you type your function here. Let me increase the font size a bit. Okay, Celsius. I call my function F1. And F1 simply returns x to the power of 2. Okay? So I've written a function, I've defined a function called F1. df stands for define, by the way. And F1 takes in one input. And I call it x. And what does it do? It actually calculates x to the power of 2 and returns that value. So I'm going to save it. Alright, I'm going to save it in my working directory, which is C/10. And we'll call this dum.py. Okay, it's not compulsory for your Python code to be in a file called something.py, but I mean, it's good practice, right? When you see a file something.py, you know it contains Python code. But it can actually be any file name, something.txt also can, but Why you don't want to do that? So now this function is still not in your memory. When you try to call f1 this case, and I pass in 4, you will get an error. It's not defined. Why? Because you have saved the file, but you have not executed the code in the file. So you need to run module. F5 lah, just remember F5. Okay, run module. So what happens is you will see that the shell is restarting. It has loaded the file, dump.py. Okay, loaded means you will read line by line. In this case, there are 2 lines. It reads it as a function and stores it in memory. Now you can call F1, and then pass in 4, and you will get 16 returned from the function. Okay, I can call it again. Unfortunately, either you can't use up and down arrow keys. You have to use alternate P for previous command. You can press alternate P a few times, previous command. So you may want to use alternate P instead of retyping, especially if your line is very long, and you use the left arrow or right arrow to edit. So instead of passing in 4, I can pass in 10, and I'm expecting 10 to the power of 2 to be returned. 100 is returned. Function is reusable in that sense. Every time you call it, you can pass in a different input value, and you will come back with a different output. So it is possible to write multiple functions in the same source file, in the same file. So I'm going to write a second function called f2, and this time f2 takes in 2 values, x and y, and it's going to return x plus y. Okay, save it, Control S, run it again, F5. Okay, always remember to run. Otherwise, if you change the code and you don't run it, when you try to call the function again, it is still the old one. So now I can call F1 and F2. Okay, look at this error. It says F2 missing 1 required positional argument. Why? Okay, look at the way I wrote F2. F2 requires 2 values to be passed in. Basically returns the sum of the 2 values. So I was trying to call F2 and I passed over only 1 value. Cannot. The error message will tell you that missing 1 required positional argument. Missing y. I passed x over but there's no y. So what should we do? F2 3, 4, and it's supposed to return 7. Alright? So I can even I can assign the return value to a variable. Okay? In this case, there's no output. Alright? But the value 7, which is returned from this function call, is stored in answer. Answer is a variable. Because I actually assign the return value to answer. If you want to check, you can always confirm that answer stores 7. Alright, I can also do something like F1, F2, 3, 4. Okay, what exactly am I doing here? Okay, what am I doing here? I'm doing 2 things. The first thing I'm doing, I'm calling F2 and passing in 3 and 4. So what will come back is 7. The second thing I'm doing is I'm calling F1 and passing 7 over. Okay, the answer is going to be 7 to the power of 2, 49. Alright? So there's a quick demonstration, and it'll be your turn to try this. Exercise T31 to T40. You'll be actually writing a function called Celsius and countertop. There's a small typo here. Basically, just remember you include this statement, double quotation mark. If you don't include this statement, when you type help Celsius, nothing will appear. This statement is just a command. It's a documentation about the function. Alright, there's a typo for T31. Okay, you can start it now. Maybe 5 minutes. Okay. So hopefully through the exercises you find easier to follow. What's happening here? Now, arguments and values passed into a function. I mentioned just now that a function can be viewed like a package of code which takes in some inputs. So in this case, the function f1 takes in 1 input. And when you pass over the input, that value is stored in this variable called x. Now when calling, you pass in 10, x will become 10. What I'm trying to show you here is that there is a kind of one-to-one correspondence. F2 here takes in two values, x, y. When you call it and you pass in two values, 10, 20, for example, 10 will be stored in x, 20 will be stored in y. The first value you pass over will be stored in the first variable here. The second value you pass over will be stored in the second variable here. Okay, that's a one-to-one correspondence. So it's also possible, before that. Now you can have multiple statements in the function. So far, the Celsius and the countertop function, these two functions which I've written, they only contain one simple statement. Very boring. Excuse me. You can have multiple statements. For example, F3. F3 takes in x and y, and in that computes the product of x and y, stores it in Z. And then the next statement returns Z. Now, not necessary, you can easily merge these two statements to return x times y. Not necessary, but I was trying to demonstrate that, you can have multiple statements in one function. Now, it is very important that you indent your statements. Indent means what? Put 2 or 4 spaces or a tab in front here. 2 spaces, 4 spaces, or a tab. Please do not use 1 space or 3 spaces. Very strange. 2 or 4 or a tab. If you use 2, be consistent, use 2. If you use 4, be consistent, use 4. Now this is called indentation. It's very important in Python. In other languages, if you have used other languages, your instructor or whoever will keep telling you, please indent your code because of readability. If you don't indent, it's very difficult to read. For Python, it is mandatory to indent. If you don't indent, it means a different thing altogether. Later, I will demonstrate. Okay, so make sure these two statements in the function are indented. Okay, if you don't indent, you get an error. Now, return and def are what we call reserved keywords or reserved words in Python, meaning they have special meanings. Def is used when you want to define a function. Return is used when the function wants to return a value to the caller. Now, you cannot choose keywords as variable names or function names. Okay, you can try, you can do something like return equals to 3 and you see an error message. Now, I was mentioning that in Python, the start and end of functions, the function starts here and ends here, right? You do not demarcate the start and end of functions using symbols. Okay. For example, in Java, you use curly braces, open curly brace and curly brace. In Ruby, there's an END to mark the end of a function. In Python, no. No symbols, no keywords to demarcate the end and start. What you do is you indent the statements to tell Python where the function starts, which is here, and where it ends. Once the next statement which is not indented, that means is not part of the function F3 already. Now you can have a function that takes in nothing. You don't always need to take in something, so you can def F3 bracket bracket colon. Okay? You can have a function that doesn't have a return statement and will not return anything. So these functions may do something but don't return anything. For example, they print something to the screen, end of story. Now you can also insert doc strings in a function using the double quotation mark. Now doc strings are basically useful because they help users of your function. I mean, it's a documentation, what the function does, what to pass in when you call the function. So doc strings are useful because you do not expect users to read your source code. Your function will be very long. You don't need users to read your source code. You just want the users to be able to use your function. For example, the SQRT function which someone has written, you don't want to read the source code. You just want to know, as a user of square root, you just want to know what to pass in and what will come back. Okay? How many values you pass in? Do you pass in a float or do you pass in an integer? Okay? So that is documented. So you can try help SQRT and you might get some useful information given to you. How useful it depends on how much the person documents. So when you write your own function, please document it carefully so that people can get some help when they use it. Now, I was trying to say that a function can be viewed as a kind of black box, which takes something like a system. The system takes in something, input. Okay, it performs something inside. You may not know what if you are just a user and not the writer of the function. and then it returns the output. So same for a function. When you call the square root function, you pass in one input. The square root function requires one input, it's an integer, okay? And it does something. Frankly speaking, I don't know how it is written. I don't know how it actually derives the square root of the input. So you can go and look for the source code. And it returns a value. So as a user of the function, you are not interested as to how the function works. You don't even want to look at the source code as a user, okay, unless you're very curious and stuff like that. Now, as a person who writes a function, you have to define the content, the code. So there are two aspects of a function. You are a writer of a function, you provide a function for someone to use. Or you are a user of a function, you use a function written by someone else, okay? And you don't want to bother about how the function is written. So there are two sides of the mirror or the glass or whatever, okay? Now let's move on. Boolean expressions. Let's move on a bit and then we can take a break. Okay. Boolean expressions. A Boolean expression is a combination of values. Okay. Just look at this. These things are Boolean expressions. A Boolean expression you will evaluate to true or false. Now in Python, it's capital T true, capital F false. These are reserved words as well. You can't do something like true equals to 3. You get error. They are reserved. True with a capital T and false with a capital F. Now this 10 bigger than 5 will evaluate to true. Okay, because 10 is bigger than 5. Now 10 is smaller than 10 will evaluate to false. So this is what we call a Boolean expression. 10 smaller or equals to 10 will be true. Smaller or equals. Now what is x equals 10? Now this will be true if the value stored in x is a variable, is 10. That means x stores 10. This expression will be false if x stores a value other than 10. If let's say x stores 3.14, then x equals 10 is false. Now this double equal sign, the two equals are stuck together. One operator is called the comparison operator, is sometimes called the equality operator. It is used to check if the operand on the left is the same as the operand on the right. If they are the same, that means they store the same value, this expression returns true. If they store a different value, the expression returns false. It is not, look at the last point here, this equality operator is not the same as the single equal sign. Single equal sign is the assignment operator. It's a very common mistake done by beginners. They use a double equal sign when it's supposed to be a single equal sign and vice versa. Double equal sign, you use it to compare two values, and it's a Boolean expression. In other words, it will return true or false. A single equal sign is an assignment operator. It's used to assign a value to a variable. X equals to 3. All right? It doesn't return anything. It's an assignment. So far, okay? Huh? So these two are not the same. There's this operator, exclamation mark equals, it means not equals. All right? Not equals. So if you want to, you can convert the last statement on the slide into this. Very stupid geek joke. Okay. Geek joke, not equals to. No one laugh, very funny. Okay, geek lame joke. Let's move on to if and else. Now, two more new keywords which are introduced now, if and else. So what do? They are conditionals. They are used to skip certain statements. So when you run a function, so far all the statements will run in sequence. First statement, second statement, third statement, then return. But it's possible to skip some statements. How? Okay, it's an example here. Tax rate is a function which takes in one value. On line 2, it will check. This is a Boolean expression, if something. So this Boolean expression may be true or may be false, depending on what is the value stored in income, which in turn depends on when you call tax rate, what value you pass in. All right? So if this Boolean expression on line 2 is true, it will go to line 3. If this expression is false, it will go to line 5. Okay? You will run the else block. So if something, do something. Else, do something. Okay, if the weather is hot, go for a swim. Else, don't go for a swim, that kind of thing. So in this chunk of code, only line 3 or line 5 will run. Never both. Only line 3 will run or line 5 will run. And which will run depends on the condition on this Boolean expression, whether it's true or false. It's like English, if something, do something, else do something. Okay, so the business logic here is people who earn less than 10K will be taxed at 0%. So this function returns the tax rate depending on the income. But people who earn more than 10K, 10K or more will be taxed at 5%. So this is how you can write a very simple function which takes in the income and returns the tax rate based on the income. Another example here, another keyword, else if, E-L-I-F, else if. Okay, so let's say that now there's a new business rule. There are 3 tiers for taxation now. People who earn more, 20K or more will be taxed at 7%. So I just have to change this. If income is less than 10,000, return 0.0. Else, if income is less than 20,000, return 5.0. Else, return 7.0. The third condition, you will run line 7 if the income is bigger or equivalent to 20,000. Okay, it's very logical. So this if, and else work together as one single block. One single block. So you're supposed to try this now. Okay, I think this has got to do with else and if. Okay, let's spend about 5 minutes on this now. Let's carry on now. So just now there was a good question. This code, this function called marginal tax rate, right, can be rewritten in this format. Look at the difference. Okay, somehow, let's say if I want to return 5.0 first, in other words, I want to detect if this person is in the second tier, meaning that he is between 10,000 equals 10,000 and below 20,000. He earns 10,000 and below 20,000. I want to return 5.0. I can rewrite it in this way. So here I check if this is true, below 20,000, below, and bigger or equivalent to 10,000. Okay, and all are also keywords in Python. Then I return 5.0. Else, if income is less than 10,000, I return 0.0. Else, all other cases, this simply means that he has to be above or equivalent to 20,000. I return 7.0. This works in the same way as the one on the screen, but it's a bit more complicated if you want to go and check the middle tier first. That is why the code given to you is actually easier to understand. So this is preferred. The one given to you is preferred because it's easier to understand. I check if it's less than 10,000, I return 0. If it's less than 20,000, that means must be between 10K and 20K, right? If this person is earning only 5K, he will have been caught earlier already. You won't get a chance to go to line 4. So what is given is easier to read and easier to understand. Although I won't say this is wrong, logically speaking, they are the same. This is not preferred because it's a bit more difficult to understand. Actually, okay lah. This is not too bad. I've seen code which is really difficult to understand. The one we hit it. So also can, if you really want to somehow check whether he belongs to the second tier first. Just that, a bit more complicated. Okay. So an if block may contain multiple statements. When I say an if block, I refer to what is in the if, what you should do when this is true in the if block. So in the example you have tried, only one statement, return something, but you can have multiple statements in the if block. So an example is shown here, the f1 function. If x is bigger than 10, do 2 things. First statement, print something. Okay, print something, that means this statement bigger than 10 will appear on the screen. Return true. Else, the else block here has got 2 statements as well. Now when calling a function, once the program hits a return statement, for example, when it hits return true, the function terminates immediately. Very important to understand this. Okay, all the other statements in the function will be ignored. Once I hit return, that's it. The function returns to the caller with the whatever value, the return value. It won't carry on. You ignore all the remaining statements. Okay, so returning from a function effectively terminates that function. So a quick case study, this function given here doesn't make sense. Why? You have line number 5, which is supposed to cause an error. But if you write this code and you run the module, you realize that, hey, there's no error given to you. Why? It doesn't cause an error. Look at the way it's written. You realize that line 3, line 4, and line 5 are in the if block. All right? Line 4 and line 5 will never get a chance to run. If x is really bigger than 10, on line 2, it will go to line 3 and return 1 and terminate immediately. There will never be a chance to go to line 4 and line 5. Okay? Therefore, line 5 will never give an error. Why? Because it never gets a chance to run. Okay? So this if you see code like that, that means the programmer doesn't really understand what is happening. He has included statements like line 4 and line 5 which will never get a chance to run in his code. So don't put it there. Okay? He may have put it there by accidentally. So bad practice. So Python is a kind of language only when that statement executes, then you may get an error from it. As long as statement 5 never gets a chance to run, you will never get an error message. Okay? It's not like Java. Java, there's a compilation phase. It will check through all the statements for you and tell you there is this line 5 which causes a syntax error. Okay? No such checking in Python. Python, you run it immediately. Okay, line 8 is another statement which will never get a chance to run in this example. Because when I start on line 2, if this is true, I'll go to line 3. If this is false, I'll go to line 7, which terminates the program. You will never get a chance to go to line 8. Now, I was saying indentation is very important. Indentation is very important. Okay, I'll explain now together with this. It's possible to use if without else or else if. Line 2 and line 3 by itself is okay. There's no need for an else block or an else if block. No need. So if x is bigger than 10, go to line 3. If x is not bigger than 10, move on. Go to line 4. Okay, there's no need for an else if there's nothing to put in an else block. So look at this. Line 4 is not part of the if block. How do I know? Because I look at the indentation. Python also look at the indentation. There's no marker to mark the end of the if block. So line 4 is actually a statement by itself. Now, as far as the f function is concerned, you can view line 2 and line 3 as one single statement. So the f function has got 2 statements. Line 2, line 3, one statement. Line 4, one statement. It's easier to view it that way. Line 2 and line 3 are independent from line 4. Okay, so after running line 2 and line 3 as one statement, the flow will go to line 4 as long as a return statement has not been encountered. Alright? So in this example, it's as good as putting else return 3 if you want to, but they do the same thing. Okay, let's move on to strings. Move on a bit and then we take a break. 10 o'clock. Okay, fast one. We have seen integers and floats. Now we'll deal with strings. Data can be stored in strings as well. Strings will basically be a series of letters, digits, punctuation marks, enclosed in quotation marks. Now you can use double quotation marks. I'm used to using double quotation marks. The textbook uses a single quotation mark, no problem. Single or double, no difference. But if you start with a double, please close with a double. If you start with single, please end with a single, otherwise you get an error. So interesting things you can do with strings, you add 2 strings together. We call this string concatenation, not string addition. Okay, but same thing. String concatenation, pine plus apple, you will get pineapple. 2 years ago, we have this pine, apple, pear, pen, don't know what, add together. Remember or not? Last year, right? Is it? That song. Okay, then S plus world is the same as concatenating a string stored in S, which is hello, and world, and you get hello world. Now remember, all these statements do not change the value stored in S, because you're not reassigning with the equal operator, with the assignment operator. You are not reassigning to s. So we will not change the value s. Now s times 3 is very interesting. What's the meaning of multiplying a string? S times 3 is a short way to write s plus s plus s. Huh? So you are going to get hello, hello, hello. Okay, there's this thing called hell in s. So you are checking whether there is this chunk of this strings HELL in s. So is hell a substring of hello? Answer is true. This is a Boolean expression which will return true or false. Now len, short form for length, is a function. The function takes in a string. You pass in a string, it tells you the number of characters in the string, the length. Number of characters includes spaces, digits, and punctuation marks. It's not only the letters, okay, remember that. And count to actually return the number of times a particular character is found in that string. Okay, some points to note after you have done the tutorial projects. In Python, a variable can be used to store a value of any type. Okay, this is quite interesting for people who may have used another language such as Java or C. In those languages, a variable has a specific type. So a variable of type integer can only store a value, an integer value. A variable of type string can only store a string. Okay, for Python, that's not the case. For Python, there's no such concept as the type of a variable. There is a type of a data, yes, but a variable like x can be used to store any type of data. So in this case, x equals to 3.14. Down the road, I can reassign x to a string. So now x equals to 3.14, then later x equals to 4. Then later x equals to quotation mark apple. Alright, it's possible because there's no such thing as variable type. Alright, x does not need to specifically, store one type of data only. So you can use the function called type to check what is the type of the data stored in x. So in this case, type x, you see this class float. Basically, x stores a floating point value. Alright, like type x is int. Y equals to true. Type y is bool for boolean. Alright, you can check if a variable is of a particular type by using the is keyword, okay, as shown in this example. So there's an exercise here, but you don't have to do it. This is actually the lab 1A. There are two parts to lab 1, 1A and 1B. So this is lab 1A. Very easy, relatively easy question. Okay, just write a function which takes in sex and age. Sex is going to be a string, M or F. Age is going to be an integer, and it should return true or false based on the age and the sex. The rule is on the first point here. So that's for your lab 1A. Now, a quick note about your labs or projects. I know Hadi went through this again, so it's going to be fast. There's one lab test on week 7, one project, altogether 30% of your whole grade. So actually, programming for this course optional, 30%. So you are given 4 homework labs. Homework labs means you do at home to prepare you for the lab test and the project. Lab test is individual, so you must really know how to code. Now labs are mandatory. Okay, if you don't submit something by deadline, I will start hounding you like a loan shark. But not assess, meaning it's participation in a way. Okay, do get help to complete your labs. Look for your TA, look for me. Okay, details will be in the lab instructions that will be released soon, including how to log into the server for you to submit your solution. So tonight, I hope by tonight I can post lab 1. I'm still troubleshooting the server a bit. Something is wrong there. Okay, so today is Tuesday, right? Tonight I will upload lab 1. Deadline for lab 1 is next Tuesday night, 1 week. Then next Tuesday I will upload lab 2. Deadline will be next Tuesday. So 1 week, every Tuesday you expect one lab to be uploaded for the next 4 weeks. So please submit by the deadline. Get help to do it. Okay, you don't have to do it alone. Suffer in silence, that kind of thing. You can't get help during a lab test, but for labs, please approach us. Now, once you submit to the server will tell you whether your answer is correct or wrong. If it's wrong, please try again. I want a working solution, not a wrong solution.
And it's very easy to submit a working solution, even for lab 3 is very interesting, but it's not easy to come up with a good working solution. So the concept of quality of your algorithm comes into the picture for lab 3. Alright? So, but it's really easy to submit a working solution. Please do not skip the deadlines, do not miss the deadlines. So lab test week 7, Hadi has changed it from week 8, Monday, okay, because some of you are going overseas, right, during the week, to week 7, Friday. So just keep that Friday afternoon, 3:30 onwards free, okay, on your calendar. I'll tell you the venue when I get the venue. Project will be later, okay, don't bother about finding a group yet. You may be assigned a group. I haven't really decided. Anyway, it's still a bit far. So, how to get help with learning Python? Review chapters 2 and 3 again. I think quite well written. Code Dummy, okay, Code Academy. I think they removed the A, right? Why? Code Academy. So, your TA is in charge of the owner of this. Please go back to him. He will tell you when to submit a screen, your URL to show that you have completed the course. Now, very important point. Unfortunately, Code Academy is based on Python 2. Okay, they haven't updated it to Python 3. And there are some differences between Python 2 and 3. It's still good. Okay, you can still good. It's still a good exercise. That's why we are recommending it. So two major differences which I've noticed so far. The first thing is that print. For Python 3, you must use brackets. Python 2, you don't need brackets. Brackets are optional. You can put brackets as well. So in Python 3, you must put brackets when you print something to the screen. Second difference is in Python 3, integer divided by integer gives you a float. In Python 2, integer divided by integer gives you an integer, truncated. All the decimal values after that truncated. The rest more or less, yeah, right. So the Python series, I'm supposed to advertise this. Hadi says please advertise this because it starts this Friday. Alright, this Friday afternoon. Okay, for the next 5 Fridays. So this is conducted by your peers and just attend. If you are new to programming, if you have nothing to do on a Friday afternoon, you know, very boring, go and attend. Okay, of course, please feel free to meet Wei Xiang and me, okay, for a quick consultation. I hope that I don't give the image that I'm very scary. Yeah, I'm quite a friendly person. So message me for an appointment. I purposely don't want to fix a slot in my office because if no one comes, I'll be sitting there like a fool. So come and make an appointment with me, talk to me over about the labs. Even if you think you are correct, you may come and talk to me. Maybe there is some way to improve your answer and stuff like that. Okay, let's move on to the next step of slides. And it's going to be really, 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 really fast. Okay. But the nice thing is, I'm following chapter 3, so you can always fall back on the textbook. I think chapter 3 is a bit long-winded the way it's written, but it's still okay. So I'm going to, in this short session, introduce a very simple algorithm. Okay, probably the first for this course, I think. Simple algorithm, not as complicated as K means. And this algorithm is used to find or to identify all the prime numbers from 1 to n. I mean, n can be anything, 20. So what are all the prime numbers from 1 to 20? What are all the prime numbers from 1 to 1 million? Okay, and in the process, we are going to learn about Python lists because we are going to use lists. I mean, the code uses lists. Now, what's a prime number? It's a number which can only be, it means there are 2 factors, at least 2 factors. We can find 2 numbers to divide. Okay, so 5, 11, 73, all these are prime numbers. A composite number is a non-prime number. Now, by definition, 1 is not a prime number. So 0 and 1 are not prime numbers. The first and the smallest prime number is 2. So you start from 2, 3, 5, 7, and so on. So this algorithm is called the sieve of Eratosthenes, some Greek person. Okay, so he invented this algorithm 2,218 years ago. It's a long, long time. Okay. So imagine someone actually came up with this so long ago. And it's used to return a list of prime numbers from 1 to n. So this is the algorithm. It's not difficult to understand. So 2 steps. First step, make a list of numbers, starting with the number 2 to n, whatever n is. Alright, so in this case,
2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to n. Let's say n is 20 in this example. You can have 1 as well, but just cross it out. Because 1 is, by definition, not a prime. Now, step 2a, repeat. Step 2a, the first number in the list is prime. So 2 is a prime. Put it aside. Go to 2b, cross off multiples of the most recent prime. So I'm going to go down the list and cross off 4, 6, 8, 10, 12, and so on. All these are non-primes because they are multiples of 2. In other words, you can find a factor, 2 factors for 4. Okay, you can find 2 factors for 6 and so on. Alright, these are non-primes. And then repeat, go back to 2a, the first number in the list is prime. So now 3 is a prime, identify as a prime. And then 2b, go down the list and cross off 6, 9, 12, all the multiples of 3. Okay, next step, 2a, 5 is a prime. Go down the list and cross out 10, 20, 15, 20, and so on. Then 2a, 7 is a prime. Go down the list and cross out 14, and so on. 21, etc. Okay, 11 is a prime. Go down the list and cross out. At this point in time, you should intuitively understand, realize that 2b is actually optional. Because there is no more multiple of 11 if n is 20. I mean, the next multiple of 11 is 22, right? It's already gone beyond n already. So there's no more need to do step 2b. You don't have to go down the list to cross off multiples of 11 because obviously there's no more multiple of 11 in the list. The list is up to 20, assuming that there's 2. So at this point, you should ring some bells and say, hey, actually 2b is not necessary when you reach a certain point. Okay? The simple way to think of it is not necessary when you are looking at the latest prime. The latest prime is already more than half of n. Okay? But actually, you don't have to carry on when the latest prime is square root of n. The reason is given is actually not difficult to understand. It's given a textbook, one short paragraph there. You can work it out yourself. It's not very interesting for this course. So 13 is a prime, 17 is a prime. Okay, no need to, and that's the n. No more numbers. So we are going to implement this algorithm. We are going to show you the algorithm in the form of a Python code. So the idea is, this diagram shows the same thing in a different way. So the idea now is you are going to create a list of numbers in Python. Okay, and go down the list to cross out multiples of 2. Then go down the list to cross out multiples of 3. Go down the list to cross out multiples of 5, and so on. Now, crossing out here, later you will see in a list, doesn't really remove the number. You just replace the value there with none, N-O-N-E. None is a value you can assign to a variable. You can do x equals to none, capital N. It means nothing. Okay, instead of x equals to 3 or x equals to a string, you can put s. You can assign none to x. That means x stores none. Okay? I don't know how to explain. It stores none. So instead of deleting the element, we are going to store none at that place later. All right, just keep this algorithm in mind. As I'm going to go back to talk about list first. So this slide basically shows you that if you want to find, use this algorithm, the sieve algorithm, to find all the prime numbers from 1 to 1 million, is going to be very tedious. You can't do this on pen and paper. You do this by writing a program to do it. Okay. So let's talk about lists first. I'm going to go fast. There's no time for you to do the tutorial projects, but you can always go back and do it yourself. So what is a list? It's also a data type. We have seen strings, integers, floats, booleans. A list is also a data type, but it's different. Why? A list stores multiple values as opposed to, let's say, an integer or float is one value. A list can store multiple ints or multiple strings. So here's an example here. A equals to square bracket 1, 2, 3, 4, 5. Square bracket to indicate that we are creating a list of numbers. In this case, a list of integers. How many values are there? 5. They don't have to be in sequence. They can be 1, 3, 99, 88, 0. Okay. If you type type A, okay, you will see list. The length of A, length A. Now, when you pass in a string to the length function, they are going to get the number of characters in the string. But if you pass in a list to length, they are going to get the number of elements in the list. So it's a bit different. In this case, number of elements will be 5. Why? Because we have 5 integers in A. Alright, another example here, B equals to da 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 da. Okay, realize that the list need not be homogeneous. So in this case, this list contains a string, an integer, none, capital N, false, a boolean, and another string. So I just want to show that a list can contain different types of values or different types of elements. Sometimes I use the word elements instead of values. Okay. How many elements? 1, 2, 3, 4, 5, 6. If you type len and you pass B in, it should return 6. Alright, the number of elements or number of values in the list B. Now those who are used to this term of arrays, a list is an array. If you don't know what's an array, better still, don't have to bother. Okay. So C equals to square bracket, that means this is an empty list. Len C is 0. Now how do you insert elements into the list after you have created it? Just use append. So C.append 99, C.append 88. So the new element is inserted at the rear, as a new last element in the list. So no time to do this. I just want to point out, is it possible for a list to contain another list? Answer is yes. You call this a two-dimensional list, and you need to be familiar with this for lab 3. Alright, this is a two-dimensional list. I'll just show this very quickly. Okay, so A is a list, let's say 4, 5, -1, apple. So this is what we call a one-dimensional list. The length of A is 4. Length 8 is 4. Okay. Now I can create a new list called B, and in B I'm going to put in maybe true, which is a boolean. Now be careful, true without the quotation mark is a boolean. True with the quotation mark is a string. It's different. Okay, there's some color differences in IDLE. I mean, to warn you that this is a string. Okay, strings are green by default. So there's a difference between true in quotation mark and in quotation marks and true without quotation marks. So I can do this A, 3, something like that. So now B is a list by itself, and the length of B is 3. Contains 3 elements. And what are the elements? The first element is a boolean, true. The second element is a list. The third element is an integer. So when I length B, it doesn't show me 1, 2, 3, 4, 5, 6. No. As far as B is concerned, it only contains 3 elements. The second element may contain 1, 2, 3, 4 elements. Alright? So this is what we call a two-dimensional list. You can have a 3-dimensional list, a 4-dimensional list, and a 100-dimensional list if you want to. So another question is, how can you insert an element to the front? Just now the append actually inserts to the back. So how? Answer Google. Okay, so this is my suggestion. One good way I think to learn Python is, for example, let's say you want to insert something in the middle of the list or the front. Google Python, how to insert an element in front of a list, or how to insert an element in the middle of a list. Enter. You'll be likely to be directed to maybe Stack Exchange or some forums. Okay, go there, click on the answer, look at answers. Okay, some people suggest this, some people suggest this. You are not sure whether it's correct or wrong. Try it in either. Either is a good place, it's interactive to try out certain concepts. You try it over there, then it works or it doesn't work. Okay, maybe what is proposed is for Python 2 point something. So if it works, then you incorporate the idea into your code. So I always do that because there are so many languages, I'm very confused also. So Google, experiment in either, then put your code. Don't put your code directly without checking, without trying. That's a recipe for disaster. Okay. So Google. Okay, another keyword I'm going to cover is for. There's a for keyword for looping. What is the meaning of looping? Looping, you want to repeat certain statements many times. Okay, that's called looping or iterating. So for x in A is a list by the way. A cannot be an integer. For x in A, statement print x. So what does this mean? That means if there are 10 elements in A, I'm going to repeat this 10 times. If there are only 5 elements in A, I'm going to repeat this 5 times. If A is an empty list, don't do it at all. Okay? So during the first iteration, the first loop, iteration means loop, X will store the value of the first element A. During the second iteration, X will store the second element in A, and so on. During the last iteration, X will store the last value in A. So what this does is basically it prints out every element in A. Okay? So you can try this yourself. But you must pass in a list. If you call print list and pass in an integer, you get an error. If you pass in a float, you get an error. Okay, so if you want to write a robust function, by right you should check before looping through. I should check what is the value, what's the type of A, just in case someone calls print list and passes in something of unexpected type. Okay, because you can't control that. Remember, you can call print list and pass in any value. Now there's another example here. Total. Total is a function which takes in a list as well. Okay. On line 2, I have a variable called sum and set to 0. Then on line 3, I'm going to loop through. That means line 4 is going to be repeated how many times? As many times as there are elements in A. Let's say A contains 10 elements. So line 4 is going to happen 10 times. Now during the first iteration, X will store the value of the first element. So I'm doing sum plus equals X. What is sum plus equals X? Sum plus equals X is the same as sum equals to sum plus X. It's just a different way to write it. This is an operator. Okay, plus equals is an operator. People use it because it's very long-winded to write sum equals to sum plus X. It's very common. There's also minus equals, there is times equals, and there's divide equals. Okay, if you want, you can use them if you want to. So what is happening is, during each iteration, okay, during the first iteration, sum equals to 0 plus the first value. During the second iteration, sum equals to the current value of sum plus the second value. Remember, X will change. X will change depending on which loop you're talking about. Alright? So at the end, I go to line 5. After all the loops have completed, I go to line 5 and I return the value of sum, which is the total of all the integers in A. A must be a list of integers or a list of floats, also can, no problem. A list of integers or a list of floats, okay? No time to do this. Now, how do you access a particular element from a list? Let's say you have a list of, in this case, a list of strings. So names equals to Sonic, Tails, Amy, and Knuckles. You know who are these people? Okay. Your generation, right? Is it? Okay, names is 0. This is the way to retrieve the first element in names. Okay, this 0 here is the index. I will call this the index or the position. Now, important to note, indexing starts from 0. Okay, in a lot of programming languages, indexing starts from 0, not 1. In other words, this is position 0, not position 1. This is position 1, not position 2. Alright? Programmers like to start counting from 0. Okay? So names 2 is actually referring to the element in the third position, Amy. Names 3 is the element in the fourth position, Knuckles. If you try names 4, you get an error. Look at the error message. It says index error. Number 4 is the index. List index out of range. There's no position 4 because there's no fifth element. Alright? You will I guarantee that you will see this error, okay, as you do your programming, because very common error. If you see this error, just check. Your index is you're trying to pull an element out and the element does not exist at that position. So -1 works as well. -1 means the last one. Count from the back. -2 is Amy, -3 is Tails, -4 is Sonic. -5 you get the same error because there's nothing in front. So that is retrieving an element from the list. What about replacing an element in the list? So you just assign names 0 equals to shadow. And if you look at the values in names again, hit enter, you see that, hey, Sonic has been replaced, okay, with shadow. So now you have learned how to create an array, how to append stuff to the array, how to retrieve a particular element in the array, how to replace a particular element in the array using the position. You have learned how to iterate through an array using for, okay? So a lot of things, you already know a lot of things. What about range? Range 0, n, as far as Python is concerned, it means what? 0, 1, 2, 3, 4, excluding 5. Another example here, range 3, 6 means 3, 4, 5, excluding 6. So I can do something like this. For I in range 0, n. So let's say that nothing to do with the array. This has got nothing to do with an array. It's just a series of numbers, a range of numbers. During the first iteration, I will be 0. During the second iteration, I will be 1. During the third iteration, I will be 2. During the fourth iteration, I will be 3. All the way until n minus 1. Remember, the range excludes n, the second number. It excludes n. Alright? So, I is what we call a loop counter. So what happens on line 8, during the first iteration, by the way, n is a value passed into the partial total function. When you call partial total, you pass in two values. The first value, n, is a number, maybe 20. The second value, a, is a list of numbers. So on line 8, what's going to happen is sum equals to sum plus a0, first element. During the second iteration, sum equals to sum plus a1, the second element. And so on, all the way until sum equals to sum plus a19, assuming that n is 20. That's the last element. So actually what this does is similar to what was done just now in the previous example, except that it's a different way of doing it. Instead of for I in A, now for I in range something to something. Okay? Now this is useful if you don't want the sum of all the elements in A. You just want the sum of the first n elements. Let's say A is a list which contains 1,000 numbers. I want the sum of the first 5 numbers. I call partial total, pass in 5, A. So this will only loop 5 times. I is 0, I is 1, I is 2, I is 3, I is 4. That's it. I only want the sum of the first 5 elements. Okay? If you use the previous way to do things, you have to, for x in A, you will look through all the elements in A. You have lesser control in a sense. Now there's another way to use range. You can put in a step. This is a step. Now if you don't put in a step, the step is by default 1. What is the step? Basically the loop counter will increase by the step during each iteration. So in this example, range 2 to 20. During the first iteration, I is 2. During the second iteration, I add 1 to I, and it becomes 3. The step is 1. Now, if you do this, 2, 20, 2, during the first iteration, I is 2. During the second iteration, I becomes 4. Not 3, 4. Why? Because it increases by 2. Next iteration, I becomes 6. And then I becomes 8, and so on. Now, by the way, this str basically converts an integer, I, into a string. Why do I want to convert to a string? Because I want to concatenate that string to a space to print to the screen. You cannot add a number to a space. Doesn't make sense. I don't know what to do. Python doesn't know what to do. 3 plus space, what does that mean? So you have to convert the 3 to a string, add it to a space. Then it becomes string concatenation. So SQRT here basically converts I, which is a number, an integer, to a string before I perform concatenation. Now this n thing is optional. If you don't put the comma n equals to quotation, basically you print on the next line. Okay? I just want to print on the same line, so otherwise very difficult to see. Okay. Okay, another way to create a list, instead of a equals to 0, 1, 2, 3, 4, etc., you can create a list like that. A equals to list, and you pass in a range. Now you can only do this if the values in A are consecutive. That means you want the numbers 0, 1, 2, 3, 4.
if your list contains 0, 100, 99, 2, -5, in random order, you can't use this range to create the list. You have to manually create. Otherwise, how do they know what values you want? So if you do this, you get the same values in A. 0, 1, 2, 3, all the way to 9. Or remember, excludes 10. Or if you want 2, 9, also can. You get 2, 3, 4, all the way to 8. Remember, excludes 9. Right? So what does this statement do? Worksheet equals to none, none plus list something. Now basically, a few things are happening here. First thing, a new array is created. Array contains only 2 elements. First element is none, second element is none. So this is one new, I use array just now, a new list. Okay, a new list is created. Now here, a second list is created. This list will contain the numbers, the integers 2, 3, 4, all the way to 99. Alright, 2, 3, 4, all the way to 99. There are actually 98 integers in the second list. Third thing which is happening, list concatenation, or adding 2 lists together. You can actually add 2 lists together to form a longer list. So these are the 3 things which are happening. And then the 4th thing which happens is that this list which is created is assigned to this variable called worksheet. Alright? So if you take a look at the value in worksheet, in either you type worksheet, enter, you will see this. Worksheet's length is actually 100. First element at position 0 is none. At position 1 is none. At position 2 is 2. At position 3 is 3. At position 4 is 4, the way to 99. 100 elements. And this is the list you are going to use for the sieve algorithm. Remember step 1? Create a list of numbers all the way to n. So in this case, n, I want to find all the prime numbers from 1 to 99. So why do I put 2 nuns in front? Because by definition, 0 and 1 are not primes. I'm going to start from 2. I'm going to go down the list and cross out multiples of 2. Cross out here means replace the value there with none. Then I'm going to go down the list and cross out all multiples of 3. Cross out means replace 6, 9, 12, all these with none. Okay, and this is the code sieve. Alright. The programmer has decided to write 3 functions instead of 1. Okay, the second function is called sieve. It is called by sieve on line 10. Alright, so sieve on line 10 actually calls the sieve function. So it's a good idea. Each function represents one functionality. Alright, so instead of writing everything in the sieve function, he decides that, okay, there's something which can be taken out and reused. I call it sieve. There's something which can be taken out and it's called non-nouns. So what does sieve do? S-I-F-T, yeah? It's like the tongue twister, sieve and sieve. Okay, let's take a look what sieve does. Very short function. It takes in 2 values, k and a. K is a number, integer. A is a list. So it removes multiples of k from list A. So this example here, let's say L is a list of numbers 0, 1, 2, 3, all the way to 9. When I call sieve, I pass in 2 and L. What it's going to do is going to replace the positions at position 4, 6, 8, and so on with none. So what comes back? L. This is not 1, this is L. This is L. Looks like 1 also. A bit different. This one is horizontal. This one is a bit tilted. Okay. So after calling this function, realize that all the values at positions 4, 6, 8 will be replaced in value. Instead of a number there will be none. Alright, another example here, I create a new list again from 0 to 9. I call sieve and I pass in 3, j. This 6 and 9. The value at that position, the 6. At position 6 is actually the 7th position. At position 9 is actually the 10th position. It will be marked as none. So this will be used to actually remove all the multiples of 2 and all the multiples of 3. Yeah? Now the other function called non-nouns, basically it takes in a list and it will return a new list with all the nuns inside removed. Okay, example, I have L, enter. Okay, so this is a list containing integers and none. I call non-nouns and I pass in L. Okay, it returns a new list with all the nuns removed. Alright, because I want only the primes, right? So after iterating through all the list and removing all the multiples, putting in nuns there, I want to call non-nouns to remove all the nuns so that I have a very nice list of prime numbers. 5 more minutes. I'm going to leave the last 5 minutes to Camelia, whom you may be familiar with. Okay, so back to the sieve function, the main one which you are going to use. You call sieve and you pass in 50, it's going to return all the prime numbers from 1 to 50. If you call sieve and you pass in 1 million, it's going to return a list with all the prime numbers from 1 to 1 million. So how does it work? Very few statements only. Numbers on line 6, it actually creates worksheet, a list, none, 2, 3, 4, 5, 6, all the way to n. 1 million, whatever. Okay, whatever n is passed in. And then here there's a loop here. During the first iteration, ignore this line 9 first. So during the first iteration, it calls sieve, passes in 2 and worksheet. So it's going to mark as none all the values at position 4, 6, 8. Then during the next iteration, it's going to call sieve and pass in 3, the same worksheet. So it's going to mark as none the values at position 6, position 9, position 12, and so on. Okay, and this carries on. So it's from 2 to square root of n. I mentioned it just now. You don't have to do 2 to n, not necessary. You just have to do 2 to square root of n. And the next question is, what is line 9 for? Why do you want to check whether worksheet K is not none? Now just think about it. There's no need to actually call sieve and pass in 4, worksheet. Okay, I'm explaining it here. There's no need to call sieve and pass in 4, worksheet, or call sieve and pass in 8, worksheet. Why? Because just now, you have already called sieve and pass in 2, worksheet. This would have already marked as none all the multiples of 4 and multiples of 8. Because a multiple of 4 or a multiple of 8 must definitely be a multiple of 2. Can I? Is that primary school maths? Can I? Cannot also okay. Talk to me later, okay? I'll go through that slowly with you, okay? So that is why there is no need to actually call the sieve method if that position is already marked up already. So the point here is the person who wrote this program did it in a very careful way. Not necessary, don't do something. Why? You save a lot of time. Not necessary, don't go and loop all the way to from 2 to n. Just loop all the way from 2 to square root of n enough. Right? Ceiling means to the nearest number. Okay, if not necessary, don't even call the sieve function. Alright, so it makes the program very fast. You don't do unnecessary operations.